right, let's just live code this. Did it? Yeah, didn't think so. Why doesn't that save? Mad annoying. Shit. This is on secret wall. I need to re-add the trigger and real char. And then we can live code this, see if it works. In the meantime, bring up my Udemy course. Udemy. 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 I'm on constructors, actually. Because I already know constructors, but I already know constructors, baby. Into the thick of it. Overlap events. Yep, I did that. Holy shnikes, I might be able to get through this today.
Hello and welcome. In this lecture, we're going to be looking at a special function called the constructor that allows us to give default values to properties in our class, and we'll see when it's called in the editor. Let's dive in and find out. Now, with this trigger component, I would like to add a tick component function in here so that we could check which components, which other actors are currently overlapping this trigger component, and we could activate if it is the right kind of actor. The problem is, well, we'll see what the problem is. Let's try and implement a tick function. If we go over to the Gamedev to see what the declaration.
Ma'am, please stop that. Into the thick of it. Into the thick of it. Oh. We're jumping through the woods. Into the thick of it. Reddit. But we can't hear where we're going. Doodle 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 doodle. I actually did not follow you. I lied. I just straight up lied to your face. Le sorry. Follow, follow, follow. Whew. Trivago. We're building, we're building.
There. 100% not his normal voice. How would I maintain it for 12 hours a day? Insane behavior. Just go to my next meet and greet and record me.
Into the thick of it.
Prime Day is here with great.
Just following a bunch of people. See if we can get some follows. Are we live? We're live, baby. We are live. Okay, so we need to go in here, add a grabber, because for some reason the grabber doesn't want to stay on. Grab. And release. Can I do this? Yes, I can. Into the thicker. And then I'll control save this. Secret wall. I want to add a trigger. Yes, yes. And we're gonna drop this in. Now we want to click on trigger and do add event for trigger on collision, I think. Begin overlap. What was it? Oh my gosh, I forget. Other actor. Spring. Ugh.
Hello and welcome. In this lecture, we're going to be creating a new component in C++, this trigger box, which will report to us when we step inside the alcove or we place any object in the alcove. You can see we're getting a little blueprint message up in the top left-hand corner. And to do that, we're going to have to understand how overlaps and blocking and different collision responses behave in Unreal. Let's dive in and find out. Now, we've already become familiar with how trace channel scroll on down to where we've got a collision preset. If we can, again, something that we can hook onto, so that anywhere we place the gargoyle in this box, it's going to accept it. And we can see that it has got collision options down here. We've got an overlap all dynamic as the default, but as the default preset. But if we hit custom, you can see we can change the object, generate overlap events as well. So then the overlap events should happen. Let's go and pick up the gargoyle, take him over to the alcove, and stick him in. And now we are getting an event coming up when that happens. The gargoyle statue is indeed being registered. Now, I don't want to be using blueprint events in this particular case. So what I want to do is take our trigger area component and actually turn that into a C++ component that can evaluate whether it's got the gargoyle statue it wants or not already in it. The way we're going to do this is we're going to go to the add components, create a new C++ component, and as the parent class, instead of choosing act component or scene component, we're going to go to all classes and we're going to search for the box component instead. And you can see the shape components, box components, the one we want, and we can go ahead and hit next. So I'd like to challenge you to create this component now that I've shown you how to set the parent class. So you're going to name it trigger components, and you're going to have to copy some things from the other components we've created because it's not set up in the same way, seeing as we're deriving from a different parent. You're going to have to copy the uClass line. That whole line is basically component begin play. And we can check that the collisions are set up area that secret wall to uTrigger component begin play. And then in here we can put in our ulog, and we're just going to write a simple message such as trigger component alive. We'll go ahead and compile. This may take a little while, seeing as we've made some fairly significant changes to our header file. And once that's done, we can go into our BP secret wall, go to add and search for trigger. And here you can see we've got that trigger component. We can now add that in. We can remove our trigger area that we've set up previously. Just go ahead and delete that and check. Yeah, we want to delete it. It's going to basically invalidate this event that we created. And we can check that the collisions are set up as we want on the trigger. We're going to have a look. Yeah, it's set to overlap all dynamic and to generate overlap events. And finally, what we need to replace is this event here, where we're going to select our trigger, right click, and go to unfurl the add event for trigger, collision, and add on component begin overlap. That's what we were using before. Hook up the actor pin, and hook up the execution pin 2. Head over to the dungeon level, go and pick the declaration of a tick component function should look like. It needs to be in the public section. It's a virtual void tick component, delta time. There's lots of parameters, so let's just copy it. Go over to the tick component header, add it in.
What do you want me to do?
Problem is, let's try and implement a tick function. If we go over to the grab.h to see what the declaration of a tick component function should look like. It needs to be in the public section. It's a virtual void tick component, delta time. There's lots of parameters, so let's just copy it. Go over to the tick component header, add it in underneath our begin play, and then we're going to copy that definition, take it over into our trigger component C. PP. And one thing that we'll notice is there's a couple of keywords here that we can remove. We can remove the virtual keyword. That's generally a rule that we can follow. We can also remove the override keyword. These are things that don't need to be in the C++ file. We need to add the class name, so uTrigger component : then we replace our semicolon
colon
with some braces, and we need to make the call to the super tick component. So because that's quite a long call, I'm going to copy it from our grabber
colon
CPP and paste it in to this one. Now what this is doing is it's essentially calling the parent's tick component function, so the parent in this case being our box component. So it's important to call that in case there is any functionality there that needs to be used and enabled for this component to work. If we don't do that, we're essentially bypassing any of that functionality and things can break. So very important to always remember to call to super when we are implementing begin play and tick component. Now let's copy our log message from begin play and put it in tick component, and instead of saying tick component live, we're going to say tick component is ticking in here, and we're going to go ahead and compile and see whether that tick is actually working. Once the compiler has finished, let's go ahead and hit play, open up our output log, and well, nothing seems to be happening. Now the reason for this is that optimization wise, they automatically in Unreal, most components have their tick switched off. So actors usually have it switched on by default, but components usually have it switched off. So in fact, if we look at some of the other components that we've got, such as our mover that we know ticking does work for, you can see that at the top of the file, there is this uMover function, and it's got this primary component tick dot b can ever tick equals true. If you don't set this property on the class, so this is a property of the class, there's a property of the class called primary component tick, and it is a struct that has a b can ever tick property within it. So what we're doing here is we are setting this default value on the mover class when we construct it. That's what this function is. It's called a constructor, and it is a function that gets called whenever we create a new mover component to automatically set default values. We can set some default values over in the header file like we've done with should move, move time, but an alternative to doing it over in the header file is that we can actually set these properties in the constructor. Now I'd like you to notice the syntax here. If we go over into the mover header file, you can see that a constructor is named exactly the same as the class. So the uMover is the class name for our mover component, and its constructor is also called uMover. Notice it has no return type either. It doesn't make sense to return anything because we are constructing a new object. We are just making this class happen. So all we need is access to the properties of this class. And also notice that it is set to public. So it's in the public section of our class definition. So I'd like to challenge you to enable ticking for yourself. So you're going to create a constructor in the header and CPP, bearing in mind that syntax that we've seen both in the mover.h and the grabber.h, you're going to enable ticking, as we've seen again in those other components in their CPP files. So just you can copy how that's being done. You can log from the constructor as well to try and see when does it get called. Is it like begin play, or does it get called before begin play, or what? Go and pause the video and have a go. Okay, welcome back. So we're going to go into our trigger component.h. We're going to create a new public section in here. remembering the colon at the end, and then we need to call it exactly the same as the class. So that's not trigger component, it's not uTrigger, it is uTrigger component in full, and then we don't have any arguments to this constructor, so we put just empty parentheses and then a semicolon at the end of the line. Now we can go over to the CPP file, and we can make the implementation here. Again, we don't need a return type, so it's just uTrigger component, uTrigger component. A bit repetitive, but that's the way it works. Then we put some curly braces, and in here we can do any of our setup code to give the default values to the class instance. So if we go over to the grabber CPP and have a look at what it's doing, you can see it's got its primary component tick dot b can ever tick equal to true. So let's type that out. Primary component tick dot b can ever tick. B is just a prefix we often use when things have a Boolean type. Set equal to true with a lowercase t. So because changes to a constructor don't always get properly propagated in live coding, I'm going to close down the editor. I'm going to rebuild from within Visual Studio Code. Then I'm going to
You can still use alarms by for loop instead of Jesus can help you. You mean the guy who's never used GameMaker Studio, doesn't know GameMaker language, and talk a lot of shit but was wrong? Pretty funny. You should look at my comment underneath this video. Imagine screaming and shitting about alarms in GameMaker saying, why aren't these renamed when you literally can't rename them? Wild behavior. It's just another like YouTube grifter trying to fight for relevance, dude. That's all that shit is.
Cheated.
All too common these days. Think you saw that one? Very strange. Yeah, it's nuts, dude. You can still use alarms by for loop instead of manually setting all to 0 with 8 lines. Those were set to 0 because it was ending the alarms. By setting them to 0, you're actually setting the alarm to off. You would know that if you've ever used GameMaker. And that wasn't all of the alarms, it was some of them. So there'd be no reason to set that to a for loop. Can't see your comment, but he deleted it. That'd be even funnier. I deleted the comment? That would be even funnier. No, it's still there. Yeah, I wrote this underneath this video. I said, it's clear you've never used GameMaker before based on your comments. Here's a quick rundown for you. Sprite Spark is not a magic number. It's a direct reference to an asset file called Sprite Spark. This is how GameMaker allows you to link sprites and other assets. When you want to use a sprite, sound, or other object, you call it by name. The functions you call that are part type create are built in that allow you to define a particle. The functions below this directly reference different aspects of this particle effect. These cannot be modified, but they can be wrapped, but this wouldn't be efficient. Having them exposed as overall allows you to modify existing particles dynamically, meaning in runtime, while the effect is running. Changing this just creates layers of obfuscation without improving usability or performance. Alarms are internal to individual objects and only reference that same object that they're inside of. When you see alarm 0, it's hitting the alarm 0 on the left side of the object there. We cannot rename these as they are tied to the object they are placed in. Cool typo. Setting an alarm 0 causes that alarm to stop. Think of this as a timing or delay function. Data types are not defined in GameMaker. You cannot define a Boolean. You can use 0, 1, or true, false at will. It doesn't do anything. None of this matters in this language. The array of the save file is to create a workable structure for reverse engineers trying to solve the ARG behind the game. It also saves this out in the exact same order in the save file. You can read about the ARG here. It's just a bunch of disingenuous arguments put up in bad faith trying to make me look like a bad programmer. And in reality, this guy has never used the engine that I'm working in, never used the language that I'm working with, and all of his points are moot as a result. You know, basic internet bullshit. Cutting Jesus released a 15-minute video reviewing you. Do you see it by any chance? Yeah, and I wrote a gigantic comment on it. We actually just went over it. Cutting Jesus obviously has never worked in GameMaker Studio or with GameMaker language, and he made a bunch of wild assumptions about the language and things that should be changed or shouldn't be changed. It's very clear he doesn't know what he's talking about. So I put a large comment underneath this, but it got buried in the myriad of other comments that you can see here. So if you want to screenshot that, you can go and read it yourself. We just went over it on stream. I don't want to do this all stream. But yeah, he's obviously never worked in this language. Yeah. So even down to like weird stuff, like why are alarms named this way with magic numbers? They're not. They cannot be changed. The engine won't allow you to. Yeah. Very cool. What's the language you said? GML. It's called Game Maker language. It is built in for Game Maker. Game Maker does not allow you to use other languages. So as a result of this, doesn't know what he's talking about. And he's bitching about shit that is not changeable inside of.
All right, now we're gonna go right at this trigger. Drag the trigger in. No, actually, want to highlight and then add event for trigger. On collision, begin overlap. Just like that. And then we can add a grabber.
Launch from the U project file. When that's done, I'm going to go ahead and hit play, have a look at our output log, and sure enough, we can see that the trigger component is ticking. So I'm going to remove that log message because it's annoying, close down the output log in Visual Studio Code, remove this log message in the tick component. We can see that it's working now. And what we did want to do is do a log in our constructor. So let's do a ulog saying constructing, see if live coding can pick it up this time. And then we're going to go to our output log and have a look straight away. Nothing showing up in here. Well, if I go ahead and hit play, have a look at my output log, I can see the log message that the trigger component is alive, and long in advance of this, actually, you can see that it is constructing way ahead when it's just creating the world. It starts constructing very early before, obviously, begin play, because we need to get the whole world ready before we start playing. So it happens when we hit play, but in actual fact, it also happens in the editor. So if I select some actor here, and then add a component to it, and add our trigger, then have a look at my output log, then you can see the constructing message was actually printed. So we need to be careful what we do in our constructors, because it actually gets called, the C++ code gets called just when we're editing, not even playing our game. These objects are being created and therefore set up and therefore need to call their constructor. I'm going to go ahead and delete the trigger again.
Tick component is ticking. You telling me I need to freaking recompile this?
And clear up a little bit by removing our constructing log message and our begin play log message as well. Great stuff. So in this lecture, we've seen how we can set up our own components so that they're almost identical to the ones created in the templates for scene components and act components. We've seen how to use a constructor to give default values to properties in our class. I'll see you in the next lecture. Hello and welcome. In this lecture, we are going to be accessing the overlapping actors in something called an array so that we can be printing out the actors that we see inside this volume entirely from C++. Let's dive in and see how it's done. So as in previous analogies, let's imagine that a type or a variable is a box in which we put a value. Now, what happens if we don't know how many values we want to store? We might create lots of variables. If we knew that we were going to have 5, we might make 5 variables. But what if we had something that is unpredictably many, such as the number of actors we have in our level, or the actors that are overlapping with a particular trigger volume? In this case, we need to use a new data type called a T-array in Unreal. And basically a T-array of a certain type. Here again, we're seeing these angle brackets that are, as we said previously, compile time parameters. And this time we're taking in again a type that is telling us what type we can store in our array. An array is like a variable, except that it has multiple boxes, and the number of boxes that we have can be different when we're playing our game. It can change. We can add more or less as we go through the game. As things start to overlap, we'd add more boxes. As things leave the overlapping zone, we'd take them away. And as I said, this is a parameter within these angle brackets, and so we could have a T-array of ints, for example, which would store different integers in those boxes. We could have a T-array of actor pointers, and this would actually store the pointers in the boxes, which would point to actors out in the world. And as you can see, they could even overlap, so that some of these pointers point to the same actors. Now, in practice, that wouldn't be very useful, but it's certainly possible. So I want to revisit the documentation of the uPrimitive component, because what I'm looking for here is a function called getOverlappingActors. And if you have a look at the getOverlappingActors function, there's a couple of versions of it, but the one that's most interesting to me is the second one. It doesn't have a return value, it's a void return value, but you can see that the first parameter here is a T-array of actor pointers with an ampersand at the end, meaning that this whole thing is a reference to a T-array. Now notice it's not a const reference, so we can assume that this parameter is actually an out parameter. It gives us the result of the overlapping actors, and it tells us which actors are currently overlapping with our primitive component. Now, it just so happens that our box component is a primitive component, so our trigger component is also a primitive component and would have access to this function. There's a second argument here, but we don't need to worry about that because it's actually got a default value if we use it. So let's go ahead and try and get hold of and populate a T-array of actor pointers. We're going to go into the trigger component CPP, we're going to go down to the tick component, and in here we're going to create an empty T-array that we can populate using this function. So the syntax is T-array, open angle brackets, a actor star, to say that we're having a T-array of actor pointers, close the angle brackets, and then we can give this variable name as actors. Then we would call to get overlapping actors, and we would pass in the actors array. Now, I don't know why they don't just pass this out as a return value, but there you go. It gives us an opportunity to use those out parameters a little bit more. Now, that's all well and good. We've got some actors in an array. There's a variable length of them. There might be quite a few. There might be 0. What do we do with arrays like this? Well, we can query how many items are in the array. You can use array.num, parentheses, and that can return an integer telling you how many items are in the array. So in this particular array, we could say there are 5. And then we can access the items inside that array by using these square brackets. And then the number that you pass into the square brackets tells you which item to get. And it's a usual convention in a lot of programming languages that we start counting from 0 in arrays. So the 0th element of an array is the first one, the 1 element of an array is the second, etc. And so you end up with the last element always being 1 less than the number of elements in the array. So how can we use this knowledge? Well, for example, we could only print the overlapping actors if there is more than one of them. So how would we do this?
Who do we got? Flatman333. What up, Flatman? Olaf from Reddit. The boy, the homie. I'll get back, sir.
Put an if statement saying that.
What's up, bro? Coding. I'm doing some game dev. Oh, turn this off. I'm following a coding Udemy Unreal Engine how to make video games. I'm making a puzzle right now. I can pick this object up and move it. Hell yeah, dude. Check it out. If I put it in here, see this, you can't see where I'm pointing on my screen because, duh. But on the bottom, wait, what? It's not coming up. Interesting. You'll score it for free. That's insane. Yeah, I love free things. Are you a music guy?
If the actors.num.
Nice. So, I mean, obviously, like, video games are, like, opening this door needs a certain sound. I'm not at any sort of, like, I'm not there yet. I got a freaking maze up top here. Don't get lost. But hell yeah, man. Appreciate that. I'll definitely keep that in mind. What kind of music?
Parentheses is greater than 0, then we can do something in here, such as...
What am I doing here? I just got an if. Rock classical piano. Hell yeah. Appreciate that. I think my all-time favorite song, that's kind of loaded, but Clair de Lune by Mr. Debussy. I think that's an all-time song.
Let's get access to our actors 0 element, because we know that if it's greater than 0, there must be at least one element in there, so the 0th element of this array must have something in. We couldn't guarantee that the...
Gotta love Chopin. I took a classical music, well, it was called musicum, so it wasn't just all classical, but I know a little bit, know enough to be dangerous.
First element, the one element of the array has got anything in, or the 2 element...
Actually, that's about the extent of my classical music knowledge. Never finish on de Bach, always finish on Debussy.
Anything in, we'd have to check whether we have enough items in the array in order to do that, but we definitely know that there is the first one here. So I'd like to challenge you to print the first overlapping actor.
Just print it? Oh, you want me to U-log? Hell yeah, bro. Keep lurking. Appreciate the follow.
From that array, use the array to get the pointer using those square brackets. Then you're going to use that pointer to call get actor name or label, and then you're going to print that out. Pause the video and have a go. Okay, welcome back. So we have got hold of the pointer here using this square brackets, and I'm then going to get hold of the name straight away by using the arrow operator and calling get actor name or label. And I'm going to put that in an F string variable called actor name. Then we're going to do a ulog, which we're going to call the overlapping colon and then %s. And then the second argument here should be asterisk actor name. Then we can recompile, hop into our output log, dock it. And then the second argument here should be asterisk actor name. Then we can recompile, hop into our output log, dock it.
Recompiling takes 5 ever.
GameMaker.
Compile, compile, compile. It takes forever to compile. There we go, there we go. I like seeing that. Build failed. Okay, what do we got? New log. Too many arguments.
Then we can recompile.
Oh, brother. Ah. See my mistake. Hector. What is my name? Hector. Compile, compile, compile. Hector. Beep 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 doop doop doop. Flat man. Compile, compile, compile.
Here should be asterisk actor name. Then we can recompile, hop into our output log, dock it in the layout. Then we're going to open up the BP secret wall because I don't want to be printing this string that confuses things in Blueprint. We're doing this now from C++. So let's go over into the dungeon level, hit play. And obviously nothing's
Successfully linked. And we're going to delete this. And we're going to play this.
overlapping that actor right now. So what happens if we go and step inside? You can see that it instantly starts printing that we're overlapping the BP player. Fantastic stuff. What if we were to go and get the gargoyle instead? Take it over to the alcove, stick it in, and there you go. It says it's overlapping the gargoyle statue. Great stuff. So we have learnt how to use a T-array.
Oh, shnikes, brother. What the fluff? No, 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 no. Secret wall. We want collision plays. Yeah. And is this collision on? Looking for collision, please. Collision. That's fine. So just pause, play this. Overlapping. Oh, that's not ideal. Wait a second. Viewport. Because this isn't right. See those cats fighting back there? Trigger. There we go. It's overlapping the secret wall. My keys. Hey, you being nice? Momo. Momo. So I'm clearly secret wall. It doesn't need to be open. Bang! With the trigger. There we go. BB real char. Yeah, baby. It's working. Shloop. I need to fix the... Yeah, what's up?
To get a list of actors and to find out how many things are in that list and how to get hold of a particular item from that list. In the next lecture, we're going to be looking at some programming structures that allow us to deal with variable numbers of things to do a variable number of tasks. I'll see you there.
While and for loops. Complicated stuff.
Hello and welcome. In this lecture, we're going to be learning how we can execute a piece of code variable numbers of times so that we can print out every object that overlaps inside this area, this trigger component. So you can see here that when I'm standing inside and there's a gargoyle too, it's printing out both the gargoyle's name and the player blueprint's name. Let's dive in and see how this is done. Now, the issue with our code here is that our actors array may have far more than just one actor in it. And if we wanted to display all of the actors overlapping, or we want to do something with all of those actors, we need to be able to run through the code. It would be highly inefficient to write an if statement for the case where we've got 2 or 3 or 4 or 5, etc. And it certainly would never catch every case because we've got a limited amount of lines in our file. So the way we deal with this, when we want to repeat a piece of code multiple times, but a number of times that we don't actually know when we're compiling the code, we need to replace our if statement. Well, our if statement essentially says, should I execute this code or not, with something that says, should I execute this code or should I execute it many times, 2 times, 3 times, 4 times, etc. The way we do this is with something called a while statement. Now, it's built very much like an if statement. So the while, you then put some sort of Boolean value inside the parentheses, and then we have some curly braces. And inside the curly braces, a block of code that will keep getting executed again and again until the condition in our while statement becomes false. That's why it's called while. So while this thing is true, execute this code. So it's a bit like an if statement in that sometimes it might not execute the code at all, but unlike an if statement that can only execute a piece of code once, the while statement could basically keep on executing it forever if this Boolean never becomes false. So why is this useful? Well, we could create an int 32 and call it index and start it off at 0. And then every time we go through the body of this while loop, we increase the value stored in that index. So we could say index equals index plus 1. Now, in C++, there is a shorthand to doing this. Instead of having to do index plus 1 like this, you do plus plus index, and that just adds 1 to whatever is stored in the index variable. Okay, so we start off at 0. Every time we go around, we increase the index. And what we can do is we can make it so that we only go around this while loop while our index is within the bounds of our array. So we can say that the index must be less than the actors.num. So that is the size of the array. Remember that when we've got 5 items in an array, the last item in the array is index 4. And so we can see that this will be true when the index is valid, when index 4 is less than 5. But as soon as that index goes past the end of the array, when it gets to index 5, then the actor number is going to be no longer, 5 is no longer less than 5, so the while loop will stop executing and continue with the rest of the function. So what that means is we could now take the code that we had above and rewrite it. Let's take it, copy it, cut it out, and stick it in here in our while loop, but before we increase the index, most importantly, because what we're going to do is replace this 0, where we were getting actor 0, we're going to replace it with actor index. So let's follow this through. How would this work? Let's remove our if statement because that's confusing matters a little bit. So we start off, the value in the variable index is going to be 0. Now imagine we have 2 actors to keep things simple. Is 0 less than 2? Yes, it is. So we go in and we get actor 0, we get its name and we log it out, and then we increase the value in index by 1. So it goes from being 0 to being 1. Now we go back to a value evaluate the while loop condition, and we say, is 1 less than 2? Yes, it is. We can then go in and get actor 1, and then we're going to get its name and print its name. Then we increase the index again to index 2. And we ask the question again in the while loop, saying, is 2 less than 2? Well, that answer is no. So we skip over the body of the while loop, and we go on and execute the rest of the code. So that's basically what we want to achieve. We want to print out the name of each actor in the array, and that's what this piece of code is going to do. Let's go ahead and compile it and check that I'm right. If we go ahead and hit play, and step into the box, you can see that we were overlapping just the BP player. What if we go and get our gargoyle? If we stick only it into the bounds, you can see that we get overlapping the gargoyle. But what if I step in as well? Now you can see it's printing both, that we're overlapping the player and the gargoyle, all in the same frame. So our while loop is working. It's executing a piece of code multiple times when there are multiple actors in the array. Now, because this pattern is so common that we have some sort of index and we increase it every time we go through the loop, there's actually some shorthand for this in C++. And if you type for in your Visual Studio Code, then there is a snippet for a for loop here that you can expand, and you can see that this is the general structure. It's got something called a size t here. We can just replace that with int32 for our purposes. And essentially what this is saying is there are 3 statements inside the parentheses of the for loop. The first one is equivalent to where we set up our index variable before our while loop. The second one is the condition, which is equivalent to what we put inside our while loop. And you can see we could replace the count with actors.num. And then the last bit is basically the plus whether you put it before or after the index is not too important, but you can see that this is increasing the value in the index, so it's equivalent to the line that we put at the end of our while loop. So this just brings together all in one line what we were having to spread out across multiple using our while loop. So here's a simple challenge for you. Convert your while loop to a for loop. You're going to copy over the body of the code, change the index from that name index to I. We typically use the abbreviation in for loops of I, just an abbreviation for index really, and compile and test. Pause the video and have a go. Okay, welcome back. So this should be fairly straightforward. We don't want the index plus plus in here, so we're going to cut the rest out. We're going to change over where we are indexing the actors array with the index variable. We're going to change that to I, the variable that's available only within this for loop. That's another advantage, by the way, of the for loop syntax, is that the I variable is only available within the for loop, whereas when we declared it here in the while loop, it's available outside, which kind of pollutes the indexes we can use later on.
You didn't follow me. You liar!
So that while loop, and you can see that the for loop is a lot more condensed, and you will get used to the slightly strange syntax that it has. Let's go ahead and compile and just check that it does indeed do the same job. If I go and grab my gargoyle and come up to the overlapping actors, you can see that indeed it is printing both of our actors when we're both overlapping in the alcove. Great stuff. So in this lecture,
great stuff. For that's a follow, baby. Spatizzle, what up, my dog? What up, my dog? Appreciate you. Appreciate you doing your thing. Keep grinding. Keep doing your thing. This needs to be int32. 0. Actors num. I plus plus. Bueno. Spatizzle, what up, dog? What up? You're grinding, bro. You're almost at, what was it, 400, 200? What was your goal?
Let's go ahead and compile and just check that it does indeed do the same job. If I go and grab my gargoyle and come up to the overlapping actors, you can see that indeed it is printing both of our actors.
I'm just going to go on the...
Hello and welcome. In this lecture, we're going to be looking at an even cleaner syntax for for loops, which we use specifically when dealing with arrays or collection types. Let's dive in and see how it looks. So this pattern of iterating over all the actors in an array is so common that we actually have our own type of for loop specifically designed for this purpose in C++. So the basic format of this for loop is called a range-based for loop. Works like this. So we start with the same keyword, we have some opening parentheses, but then instead of having these 3 statements, we do the following. We create a variable to store the pointer or the thing within the array that we are looping over. So in our case, it would be an actor pointer, which we can call the actor. Then you put a colon, and then you put the array. So that would be actors. So the way this reads is essentially for actor star actor in actors. And what that's going to do is it's going to loop over every actor star that is in the T array. Now, this doesn't only work with T arrays, it works with all sorts of different collection types. We call them collection types because they are types that contain multiple of a certain type. So this is very useful because now we've got in each iteration of our for loop a pointer to a different actor from the array. And it's just a lot cleaner and simpler and easier to read than the for loop above. So I'm not going to give you a challenge slide here. I just want you to convert from using this 3-statement for loop to using the range-based for loop instead and test out your findings. Pause the video and have a go. Okay, welcome back. So I'm going to copy over this body, and what am I going to need to change? Well, instead of accessing the array directly with an index, we now have our actor pointer variable. So we can just use actor, get actor name or label. That's the actor name, and that's what we're printing out. Now we can get rid of the old for loop. We no longer need that. And we can go ahead and compile. Once it's done, let's go ahead and hit play, grab a gargoyle, and go and step inside. And sure enough, it's printing out the gargoyle statue and the BP player when we're both in the alcove. Great stuff. I'll see you in the next lecture.
Actor tags.
Hello and welcome. In this lecture, we're going to be seeing how we can add a tag to our gargoyle actor that makes it be the only actor acceptable to our secret door. Let's dive in and see how this actor tagging system works. Now, we don't want our trigger to be responding to every single case where we get an overlap. No, we want it to be responding very specifically only to one actor, the gargoyle. So how do we go about configuring this trigger so that the gargoyle is the only thing it responds to? Well, fortunately, there is a mechanism for tagging certain actors with certain strings to say that it has a specific property. So if you go and select the gargoyle actor and scroll down in the details pane, you're going to find and in fact, you can probably just search for it. You can search for tags. And particularly, we're looking not for component tags, but actor tags. You can see that there is an array element. Now we understand what arrays are. So you can have multiple tags. It's an array of strings. So the first thing in this array is you can add it with the add button. You can delete elements from it with the delete button. And then you can add in a string. So for example, we might want to put in a string that says it's going to unlock door 1. So we'll put in a string that says unlock 1, for example. And then what we want to do is check whether that string matches unlock 1 over in our trigger component CPP. So what we can do here is we can query the actor when we're going over the overlapping actors in our for loop, and we can check whether it has a particular actor tag. It's very easy to do. There is a function for it. So we do actor, arrow, actor has tag, and then you just have to pass in the name, the F name of the tag, which you can actually just use a string to put this in. So what we can do is we can put in unlock 1, like so, and we can put a semicolon at the end of the line, and we can wrap this in an if statement. So it's saying if the actor has tag unlock 1, then let's print out a log message, which is going to basically be that log message saying that we're overlapping. We can say actually unlocking instead, so that's clear that there's a difference. And otherwise, if it doesn't find anything to unlock it, it's not going to print anything out. And let's remove the use of actor name so that all the log message says is that we are unlocking. Now let's recompile. And once that's done, let's open up our output log and dock it to the layout so that we can see the results. Let's go and start near our gargoyle, hit play, pick up the gargoyle, take it to the alcove. I just want to show you that if I step in, there is no log message. There's a log message coming from the BP player. We could remove that log, but there's nothing coming from our trigger. Now let's take the gargoyle and stick it in the alcove. And there you go. It can see that it is unlocking because of the tag that we have applied. So let's challenge you to make the tag that we've got there configurable. At the moment, we've just hard-coded it into our code. So you're going to create a new editable U property that's type should be an F name so that it matches what the actor tag is expecting. And you're going to replace your fixed string with this in the code and configure it in the level instead, which is the right place, so that we can reuse this trigger in multiple places. Pause the video and have a go. Okay, welcome back. So we're going to go over to the header file for our trigger components. We're going to go in to the bottom and create a new private section and put a U property, edit anywhere. And it's going to be of type F name, not a pointer to an F name, an actual F name, which we're going to call the, I didn't tell you what to call it, but hopefully you try to think up a good name. I'm going to call this the acceptable actor tag. Give it no default at the moment, and go over into our trigger component CPP, and instead of using unlocking in here as the actor tag we're checking for, we're going to check for the acceptable actor tag. I'm going to go ahead and compile this. Then I'm going to go and find our secret door. Going to go and find the trigger component. And you can see that I'm still got.
Gotta recompile. Takes 1,000,000 years to recompile. Takes 1,000,000 bajillion years. A million bajillion years, Momo. Failed. Failed. Oh, what did I do? I'm a failure. I'm a failure. Okay, where is it? 2542. If. That shouldn't be there. Yeah. Great. Now I get to spend another 1,000,000 years waiting for this to compile. 1,000,000 years. There we go, compile. Compile, compile, compile. Yeah, we successfully linked it. Yeah.
The search for tag, so acceptable actor tag shows up straight away. And we're going to put unlock 1 to make sure.
Acceptable actor tag. Tag. Wait, that was in trigger. Secret wall. Secret tunnel. And trigger. Acceptable actor tag is unlock 1.
Sure it matches the gargoyle exactly. The string has to match perfectly, and that should have exactly the same result. Do go ahead and test it for yourself, but I'm not going to in the video. Great stuff. So now we've seen how we can tag actors with strings to give them certain gameplay meanings and do that reasonably configurably and flexibly from within the editor. I'll see you in the next video.
I'll see you in the next lecture. All right, I'm going to call it here. Let's play some craft. I yearn for the mines.